Greetings everyone. We are Group 13 and today we'll be presenting about communication system.
In the world around us, there are various forms of communication systems, such as telephones, telegraphs, mobile devices, and computers. All these systems involve the transfer of information signals from one point to another, which encompasses transmission, receipt, and processing. Most of you are familiar with modulation, but do you truly understand its meaning? During the modulation process, a message signal is used to alter a carrier signal to produce the transmitted signal. This is especially important for long-distance signal transmissions where high-frequency modulation is required. There are two main types of modulation: analog and digital. Analog modulation is the process of transmitting an analog, low-frequency signal such as audio or TV over a higher frequency signal such as a radio frequency. Analog modulation can be further divided into amplitude, frequency, and phase modulation. Amplitude modulation, also known as AM, is the fundamental modulation process in communication systems. In AM, the amplitude of the carrier signal is varied in proportion to the message signal. The resulting modulated signal forms an envelope and the amplitude is limited by this envelope. In frequency modulation, also known as FM, the modulated signal has a higher frequency wave at the instant of the peak of the modulating signal. Lastly, in phase modulation, also known as PM, the modulated signal has the highest frequency weight during the rising edge of the modulating signal. In the next section of our presentation, we will discuss digital modulation. This is the process of encoding a digital information signal into the amplitude, phase, or frequency of a transmitted signal. Similar to analog modulation, digital modulation has three types: amplitude, frequency, and phase shift keying. The major difference between analog and digital modulation is that the modulating signal is now a digital signal. In amplitude shift keying, the digital signal is applied to switch the carrier amplitude between high and low, resulting in a modulated signal only when the digital signal is on. In frequency shift keying, a high-frequency waveform is obtained when the digital signal is switched on. In phase shift keying, changes in the amplitude of the digital signal indicate a 180-degree phase shift in the modulated signal. In ASK, the amplitude of the carrier wave is changed to two or more discrete levels, each corresponding to a specific digital bit value. The two most common types of ASK are binary ASK and quadrature ASK. In BASK, the amplitude of the carrier wave is either high or low, depending on the bit value. In QASK, the amplitude of the carrier wave is one of four discrete levels, allowing for the transmission of 2 bits per symbol. ASK is relatively simple to implement and has a relatively high power efficiency, but it is more susceptible to noise and interference than some other digital modulation techniques, such as phase shift keying and frequency shift keying. One of the major drawbacks of ASK is that the amplitude of the signal is affected by the noise and interference, which makes the signal hard to be detected and decoded. Frequency shift keying is a type of digital modulation technique in which the frequency of a carrier signal is varied to represent digital information. In FSK, the frequency of the carrier signal is shifted between two discrete values, corresponding to the digital signal's bit values. The most common form of FSK is binary FSK, in which the two frequencies represent the two binary digits. FSK is particularly useful for communication over noisy channels, as the receiver can distinguish between the two frequencies even if the signal-to-noise ratio is low. It's also widely used in low-cost and low-power wireless systems, such as Bluetooth, Zigbee, and cordless phones. The main parameter for FSK is the frequency deviation, or delta F, which is the difference between the two frequencies. In PSK, the phase of the carrier signal is shifted between two or more discrete values, corresponding to the digital signal's bit values. The most common form of PSK is binary PSK, in which the two phases represent the two binary digits. PSK is a more robust method compared to amplitude shift keying, as the phase change is not affected by the amplitude noise. Also, it requires less transmitter power than QAM, which in turn reduces the cost of the equipment. It's also widely used in high-speed wireless systems such as Wi-Fi, GSM, and satellite communications. The main parameter for PSK is the phase change, or delta phi, which is the difference between the two phases. In the field of communication technology, specifically 5G technology, 5G, or fifth-generation cellular network technology, has the potential to greatly benefit society in various ways, such as in the economy, healthcare, and industry. In terms of the economy, a study by IHS Markit estimates that 5G technology will generate $13.2 trillion in economic value and create 22.3 million jobs by 2035. Additionally, in the healthcare sector, 5G enables faster and higher quality communication with less delay, allowing for greater access to mobile health services, regardless of location. Furthermore, 5G technology also has the ability to revolutionize the way we work and conduct maintenance, by making remote working and remote maintenance possible, thus reducing operational costs. In transportation, 5G technology can also make self-driving vehicles a reality, by allowing for remote control of cars and trucks, which can ultimately reduce the number of accidents and fatalities. However, there are also some misconceptions about 5G technology. Some people believe that 5G technology generates electromagnetic fields that can reduce cognitive function and cause cancer, but studies have shown that there is no solid link between these effects and the electromagnetic fields generated by 5G. Additionally, some people also think that 5G technology is more vulnerable to data breaches, but 5G is built with a zero-trust approach to data access. That's all from our side. Thank you for listening and hope that you got the knowledge that you need. Thank you.